Now, this one is on set builder notation, as you can see. And what we start with is we see that we have a y with this line here and another y less than 9. Now, you've seen y less than 9 probably quite often in your math careers. But what we do is we read that as the set of all numbers y such that y is less than 9. So this is just your such that. Okay? Set of all numbers y such that y is less than 9. Now, here's a must. We need to use squiggly brackets. They're tough to draw, but that's what we're going to be using in today's assignment. We do not use parentheses. We will see that a little later down the page here. Okay, couple examples. If we have x greater than 6, we just write, we do our squiggly line, and then x, another line, x greater than 6. So x such that x greater than 6. If it's less than or equal to negative 3, we would write t such that t less than or equal to negative 3. This isn't too hard, is it? Then we have y is in between and including negative 11 and 14. We would write y such that negative 11 less than or equal to y, less than or equal to 14. And our last example on this part, we have a negative 2 less than x less than or equal to 7. We would just write x such that negative 2 less than x less than or equal to 7. Notice squiggly lines. This isn't too tough, is it? Now, if the set includes whole numbers, which we use w for whole numbers, or z for integers, it's a special case. The notation also includes what is called the element sign. Kind of cool looking deal, isn't it? It's almost like a little bit of a weird C with a line through it. Remember, integers do include negative whole numbers also. All right, so this first example, we have 14, 15, 16, and so on. So we would write x is an element of the whole numbers such that x is greater than or equal to 14. Remember, you have to have the underline for equal to the 14. Then you'll notice here we have negative numbers. So that means we have to change from w to z because we're talking integers here. Y is an element of z such that y greater than or equal to negative 7. All right, now we go on to interval notation. Okay, interval notation is another way to describe the solution set of an inequality. Now we're going to be using parentheses or brackets. Okay, now parentheses are used to indicate that the endpoint is not included. So it doesn't include, like for example, you see this x is greater than 6. We'd use a parentheses and a 6, meaning it does not include 6, but it runs from 6 all the way up to infinity. Now you don't need the plus sign here, but you can do it if you want. But this is telling us that it goes from 6 up to positive infinity. Now you'll notice there's a bracket wherever you have infinity because infinity goes on forever, so there is no endpoint. Okay? Now if t is less than or equal to negative 3, okay, now you'll notice we go down to negative infinity because it includes all the numbers less than negative 3, so it goes to negative infinity. And it does, this time because of the line underneath, less than or equal to, it does include the negative 3, so that's why we have our bracket. This one should look familiar from up above, 14, 15, 16. All right, this one we would have includes 14 and goes up to our positive infinity. Okay, again with the parentheses. Then this one, you'll notice we have a negative 2 and a 7, so we write negative 2 and 7 with the comma in between, but notice we do not have a line underneath here, so that is not included, but we do have a line under here, so 7 is included, so we have the parentheses. Okay, so that's two different ways of looking at notations. Talk to you later.